students, today we will study the valence bond theory for bonding in coordination compounds. Today we will study what are the assumptions of this theory. Now, assumptions. What this theory says, I will explain it here. Now, first, there are assumptions. First assumption is the central metal atom. In case of coordination compound, their central metal atom and the ligands are attached to the central metal atom through the coordinate bond. Now the theory says the central metal atom or ion makes available a number of orbitals. Central metal atom makes available a number of orbitals which are empty. It makes available empty orbitals for formation of coordinate bond with the ligands. So first assumption is that the central metal atom makes available a number of empty orbitals for formation of coordination bond, for the formation of coordinate bond with ligands. Now the number of orbitals available, the number of orbitals made available is equal to coordination number of the central metal atom, is equal to coordination number of central metal atom. For example, if coordination number of the metal atom is 4, that means 4 orbitals are available. If it is 6, that means 6 orbitals, 6 empty orbitals are, so there are 6 empty orbitals. In case of 6 coordination number, 6 empty orbitals are available. And if it is coordination, if it is 8 empty orbitals are available. Now, for example, so first assumption you have read. Now second assumption is, now the orbitals which are made available, the appropriate orbitals. I have written here the word appropriate. That means s orbital or p orbital and d, s, p and d. These appropriate because in hybridization these orbitals, appropriate orbital s, p, d, hybridize. That means there should not be much difference in the energy. So I have used the word appropriate. These appropriate orbitals, s, p, d orbitals hybridize and give a set of equivalent orbitals of definite energy, of definite geometry. Appropriate orbitals, that means those orbitals hybridize which have almost approximate energy, and these orbitals hybridize. And hybridization, when the hybridization takes place, these hybrid orbitals are oriented towards the fixed space, in the spatial arrangement takes place. Now they give a definite geometry of the molecule, they give the definite geometry. For example, if the coordination number is 4, that means 4 orbitals are here. So here, that means it can be sp3 hybridization takes place, so the shape will be tetrahedral. This is coordination number, this is hybridization, and that will be the shape here. Now if it is, again, it can be 4, so it can be d sp2, so it can be square planar. If its coordination number is 6, like it is first 5, so it can be sp3d, so it can be trigonal bipyramidal. It can be 6, so it is sp3 d2, it is octahedral. It can be again 6. It can be D2sp3. So it is again octahedral. That means the equivalent set of orbitals, that means those are definite and appropriate orbitals, they hybridize and give the set of equivalent orbitals. That means equivalent, those orbitals which have equivalent energy and with the definite shape. You have seen that it can be sp3, if the coordination number is 4, it can be sp3 hybridization, so the shape will be tetrahedral. Coordination number 4, it can be dsp2 hybridization, scalpel shape. And if it is coordination number, it is 5, it can be sp3d trigonal bipyramidal. It can be 6, so sp3d2, it can be octahedral, or it can be d2 sp3 hybridization, again coordination number 6, it can be octahedral. So now third assumption is d orbitals made available. जो d orbitals available होते हैं, they can be inner d orbital. I will explain what are inner d. For example, that means n minus 1d. For example, if it is 4s, let it is 4s, so that means it can be 3d orbital. N minus 1, 4 minus 1, it can 3d orbital. So this will be inner d orbital. Or that means it can be 2 orbitals from 3d, 1 orbital from 4s, 3 orbitals from 3p. So 2 orbitals from 3d, 1 orbital from 4s, and 3 orbitals from 3. So it will be dsp, for example, dsp3. For example, if we take, it can be outer d orbital, that is nd orbital. If it is 4s, it can be 4p and 4d. That means one orbital 4s, 3 orbitals 4p, and 2 orbitals from 3d. So that means d orbitals can be either inner or outer d orbital. When we use inner d orbital, then inner orbital complex is formed, and when outer d orbital is used, it is then outer orbital complex. So स्टूडेंट नाउ द ईच लिगेंड, अब लिगेंड जो है, ईच लिगेंड हैज at least one lone pair of electron, because the central atom has made available the empty orbital, but each ligand has at least must have one lone pair of electron. Now empty orbital of central metal atom overlaps with the ligand orbitals, with ligand orbital having lone pair, and so form a coordinate bond. A coordinate bond is formed. Form a coordinate. Let's explain this. I will explain. Let it is Cr. Example is Cr. This is NH3 whole 6 hexaamine chromium third ion. Let us explain this. Hexaamine chromium third ion, it is complex. So here atomic number of chromium, it is 24. So I will write outer electronic configuration, it is 3d5 4s1. So I will explain it here. Let 3d5 this is 3d5, 1 electron, 2 3 4 5, 3d 5, and there is one, this is 3d5, and it is 4s. This is 1 electron in 4s, and there are 4p orbit, there are 4p p for this 4p having 3 orbitals. Now I will write in chromium is in here, it is in 3 oxidation state, third oxidation state. I will write chromium third. So in chromium third, one electron from this 4s, this electron, it will get lost, and two electrons from the inner d orbital. This is 4s, two electrons, that means this electron and this electron, it will get lost, and we will get 1 here, 2 and 3. That means now this is 3d orbital, 1 3d, this second 3d, this is 4s, and there are 4p orbitals. This is 4p, 3 orbitals of 4p. So these are empty. This one is empty, this one is empty. So there are 1 2 3 4 5 6 orbitals are empty. Now 6 here, there are 6 ammonia molecules having lone pair of electrons. They will combine here. First they will hybridize. These orbitals will hybridize and will form dsp3. That is d2, two electrons from two d orbitals, these one it, and 4s, one orbital from 4s, and 4p orbitals. It will be d2sp3 hybridization. d2sp3 hybridization will take place. So the shape will be octahedral. Here shape will be octahedral shape. Now here will come the electron from one ammonia molecule, one lone pair here ammonia molecule, and this ammonia molecule here, another. They will hybridize, they will overlap. Six ammonia molecules will having lone pair of electrons, they will hybridize with 6 empty orbitals. So it will be this complex Cr NH3 whole 6, and it will be, here it is octahedral complex. Now you see, students, here are 3 1 2 3. These 3 orbitals are having, these are lone, these are having single electrons, that means unpaired. So this complex will be paramagnetic, because there are lone pair of electrons, there are lone electrons. So pairing has not takes place in the energy, so that is it is paramagnetic. Now I will explain it by another example, that it is CONH3 whole 6 tripositive ion. Now this complex, cobalt ki oxidation, cobalt G, it is 27 atomic number, so it will be 3d7 4s2. I will show it here. It is 3d7, 1 2 3 4 5. Now here 6 and 7. That means there are 2 orbitals while pairing has taken place, and this is 4s. There are 2 electrons, and there is 4p, which is empty. So now cobalt, here it is +3 oxidation state. So cobalt third, that means 2 electrons from the 4s will be lost. Now these 2 electrons, 4s electrons will get lost, and there are, this is 4p, 4p orbitals, these are already empty. Now here which electron, this electron will get lost. First pairing जो है अब unpairing हो जाएगी. That means here there are 2 electrons, and this electron will get lost. Now there are 1 2 3 4, 1 2 3 4 unpaired electrons, because one electron from this orbital has got lost. So now this complex is diamagnetic. It is diamagnetic. So that diamagnetic means pairing has takes place. So now these I will write here. This is chromium third, 1 electron, this 2 electrons from this, and these are lost. Now this is empty orbital. So now pairing takes place. Three D 7 1 2 3. It has got lost 1. Now this electron has got lost. Now there is 1 electron here. Now pairing will take place here. I will show pairing here. So there are already 2 electrons. Now this electron will pair here, and again one pair will be formed. Now there will be 2 orbitals will remain empty. These two, 1 and 2, because pairing has these electrons come here and pair, so 2 orbitals will be empty here. Now there are empty orbitals. These are now 6 ammonia molecules. They will first hybridize D2sp3 octahedral shape. Now here one ammonia molecule here, one ammonia molecule here, one here, and 6 ammonia molecules will having lone pair of electrons will overlap, will donate electron in these orbitals, and they will be CONH3 whole 6 tripositive complex. The shape will be octahedral.